Good evening to all. Myself, Dr. Yogendra Dohare. Today we discuss in the topic of performance of transmission lines. Okay. So first, performance of the transmission line. Transmission line basically it is a medium for transmitting of power from one end to another end. The transmission lines basically we classified in three categories based on the distance and voltage level. The first transmission lines we classified short transmission line. This short transmission line is length up to 60 kilometers and comparatively low voltage is less than 20 kilovolts. And second transmission line we classified medium transmission line. The medium transmission line is length 60 kilometers to 160 kilometers and line voltage range is 20 kilovolt to 100 kilovolts. And third line we classified is called long transmission line. Long transmission line is length more than to 160 kilometers and up to 1000 kilometers, and voltage level range is obviously greater than to 100 kV. So, next we discuss in detail short transmission line. Short transmission line we represent in the equivalent circuit diagrams a series line impedance and where his source is connected, this end is called sending end, and here is voltage is called sending end voltage, and other end where load is connected is called receiving end, and there is voltage receiving end voltage. Similarly, in terms of current is called sending end current and receiving end current, and this is the line impedance. Series line impedance Z equal to V right R plus Jx. This is the series line impedance. In this short transmission lines, we neglect the shunt capacitance and conductance. That means shunt parameters we neglect and we consider only series parameters. Due to short length of the line, capacitance effect we consider neglect, and we can write the equation by using this model and also draw the phasor diagram. So, first we draw the phasor diagram of this equivalent circuit. How to draw? In this phasor diagram, first we consider the reference phasor. Here is the reference phasor. Here is the reference phasor. Receiving end current. First we draw the reference phasor, and in our case reference phasor is receiving end current IR, and we assume load is connected is the lagging load. So, VR and IR behaves like a lagging. and next phasor is adding in VR. This phasor is represent the loss. I into R. I into R, this phasor is represent the loss in resistance, and next phasor represent the loss of reactance. JIR into X is the drop in the reactive component. And the resultant phasor VR and IR into R and IR into X is VS. So VS is the sending end voltage, this phasor, and VR is the receiving end phasor. IR into R is the drop of the resistance, and JIR into X is the drop of reactance. So this is the phasor diagram, and phi R is the phase angle at the receiving end, and phi S is the phasor at the sending end. Here IR equal to IS, we assume. Okay. This is the phasor diagram of short transmission lines. So by using of this phasor, we can write the equation Vs cos phi s equal to Vr cos phi r plus IR into R. This equation we write by using of these phasor diagrams. And next equation we can write Vs sin phi s equal to Vr sin phi r plus IR into X. So this is the two equations, equation number 1 and equation number 2. Equation number 1 and equation 2. Now next we proceed to squaring and adding of this equation, squaring and adding of equation 1 and equation 2. Okay. Equation and squaring and adding of equation 1 and 2. So we get Vs equal to Vr under root of 1 plus 2IR upon R cos phi r plus 2IR into X sin phi of R divided by Vr plus I square R upon V square R square plus X square. So squaring and adding of these equations first and 2, we get Vs equal to Vr under root 1 plus 2 IR into R upon VR into cos phi r plus 2 IR into x sin phi r upon VR plus I square r upon V square r in brackets r square plus x square. In practice, the last term under the square root, last term under the square roots sign is generally negligible. So, therefore, we can write Vs equal to Vr 1 plus 2 IR into R upon VR cos phi r plus 2 IR into x upon VR sin phi r. The term within the simple bracket is small as compared to unity. This term in bracket is small compared to unity. So, next we using binomial exponential and limiting only to second terms. So, Vs nearly equivalent to Vr plus IR into R cos phi r plus IR into x sin phi r. This is equation after using the binomial exponential and limiting only to second terms. Here Vs is the sending end voltage corresponding to a particular load current and power factor condition. So, in this condition it can be seen from the equation circuit of the short transmission lines that VR under the no load condition, because V dash R equal to Vs. Here V dash R is the no load voltage. So, regulation we can write regulation of the short transmission line Vs minus Vr upon Vr into 100. This is the voltage regulation of the short transmission line. And next, we discuss medium transmission line. The medium transmission line is the range of length up to 160 kilometers. So, medium length we consider series line impedance parameters, as well as shunt capacitance. Sending end voltage, receiving end voltage, and this is the series impedance, and this is the shunt capacitance of the whole transmission line. Here the parameters are assumed to be lumped. The shunt capacitance is either assumed to be concentrated at the middle of the line or half of the total capacitance is concentrated at each end of the lines. So, medium transmission line we can model in three types. One is nominal pi method, pi model. Second one is nominal T method, T model, and third one is end condenser method. Medium transmission lines model we can represent in three methods: nominal pi method, nominal T methods, and end condenser methods. So, next we discuss nominal pi method. Nominal pi methods model in nominal pi method model methods, the capacitance of the transmission line we divide in two parts. One part is connected near to sending end and other capacitance connected near to receiving end. So, here is the series line impedance and this is the shunt capacitance of the whole length of the line. Now, in this model we draw phasor diagram. So, phasor diagram looks like first we draw the reference phasor. Here is our reference phasor, receiving end current IR. And VR is